may have relaxed in a natural hot springs pool, or seen the old faithful geyser blasting hot water into the air in Yellowstone National Park. But have you ever thought of where all that heat comes from? Well, it comes from deep beneath the surface of the Earth, and it's called geothermal energy. And we can use it to generate clean, renewable electricity. Geothermal energy can also help recycle wastewater. In California, wastewater from the city of Santa Rosa is injected into the ground to generate more geothermal energy. Some plants do produce solid waste, but that solid waste may contain minerals that we can remove and sell, which lowers the cost of this energy source. The U.S. Geological Survey estimates that untapped geothermal resources in the United States, if developed, could supply the equivalent of 10% of today's energy needs and cut our dependence on fossil fuels. In fact, electricity generated by geothermal energy already provides about 60% of the power along the Northern California coast, from the Golden Gate Bridge to the Oregon state line. Geothermal energy, helping to push America toward energy independence and a clean, renewable way to meet our growing energy demands.
The sun. Every day, the sun shines more than 3 trillion watts of free energy on the Earth. That's enough energy to power over 3 million homes for an entire year, being produced every day. Solar panels harness the energy and convert it into clean electricity to power our homes, businesses, and lifestyles. Light from the sun stimulates electrons on a solar panel. These electrons create DC, or direct current electricity. Solar electricity travels from the panels on your roof through an inverter to the circuit breaker panel of your building. An inverter changes DC electricity into usable AC, or alternating current electricity, before sending it to the breaker panel of your building. Your home uses that electricity to power the electronic devices we use every day.
Hydroelectric power was the great renewable energy source of the 20th century, and it will continue to provide gigawatts of power. But with most of the world's rivers already dammed, the future of hydropower will come from the sea. Of the various technologies to capture the ocean's energy, a tidal barrage is the closest in design to traditional hydropower. The barrage is essentially a dam, collecting water from high tide until there's sufficient potential energy for power generation, then forcing the water through turbines when released during low tide. The world's largest and oldest tidal barrage at Lorence, France, began producing power in 1966. Today, it still powers 240,000 homes. A more recent technology known as tidal stream power uses propeller-like turbines to capture the kinetic energy of underwater currents.
One of the ways we can produce electricity is by using wind turbines to harness the force of the wind. But how does that happen? The answer is much simpler than you might guess. It starts when the wind blows and slowly turns a turbine's blades. In the main housing, called the nacelle, there's a lot of components for stability and direction, but the key components of a common configuration of wind turbine are the drive shaft, the gearbox, and the generator. The force of the wind turns the blades, which turn the drive shaft. The drive shaft has a large gear in the gearbox that turns a smaller one. Because the second gear is smaller, it turns faster, fast enough to make electricity. That second gear turns a rotor. This rotates inside a drum of wire coils called a stator. The rotor excites the electrons in the stator, creating an electrical current. This process works exactly like the alternator in your car.